I want to go over with you the quiz that you took last. It was a quiz on integers, all the things that we've learned about integers so far. All right, excuse me. It started with number one, said give the additive inverse of a positive 3. And again, what you need to know here is additive inverse means the opposite. And to get the opposite of a positive, you make it a negative, because a positive 3 means 3 places to the right of 0. The opposite of that would be a negative 3 places to the left of 0. So additive inverse is the opposite. That was number one. Number two asks you for the absolute value of a positive 3. And absolute value is the distance of numbers away from 0. And distance can never be negative, so absolute value is always positive. So the absolute value of a positive 3 is a positive 3. And again, they both start with A, additive inverse and absolute value, but they don't mean the same thing. Additive inverse means give the opposite. Absolute value means make it positive. Now, if this would have been the absolute value of a negative 3, it still would have been a positive 3, because you always make it positive. And the third one said, tell, excuse me, which is larger, a negative 8 or a positive 3. And again, I told you the easiest way to do this would be think of positive as having, negative as owing, and the one you rather would always be the largest. So which would you rather, owe $8 or have 3? And unless you're some kind of weirdo, you'd rather have $3 than owe 8, so the answer is a positive 3. And again, that's how number one was a negative 3, number two was a positive 3, and number 3 was a positive 3. Now we get to working with them. And this is where you have to really understand your integer rules. Number 4 says a positive 349 plus a negative 564. And again, your integer rule for addition says same signs, add and bring down the sign, different signs, subtract and take the sign a larger amount. So the first question you ask yourself when you're adding is, do you have the same sign or different signs? I have different signs, a positive and a negative, so my rule says subtract and take the sign a larger. I can't subtract 564 from 349 because it's bigger, but I can use the commutative property of addition to put the negative 564 on the top, the positive 349 on the bottom, and then I can subtract, borrow from the 6 and make it a 5. 14 minus 9 is 5. 5 minus 4 is 1. And 5 minus 3 is 2. So your answer is 215, but then you have to figure out the sign. You take the sign in a larger amount, not the larger number, the larger amount. And 564 is the larger amount, and it's negative, so your answer is a negative 215. So again, when you're adding, you a different sign, subtract and take the sign a larger amount. The next one was another addition problem. It said a negative 385 plus a negative 749. Again, the first thing you ask yourself is same signs or different signs. This time I have the same signs. So the rule says same signs, add and bring down the sign. 5 plus 9 is 14, carry your 1. 1 plus 8 is 9, plus 4 is 13, carry your 1. 1 plus 3 is 4, plus 7 is 11. That's 1,134. And again, if you have the same signs, you add and bring down the sign, so it's a negative 1,134. So again, we had two addition problems. In one, we had different signs, so we actually subtracted and took the sign of the larger. In the other, we had the same signs, so we added and brought down the sign. Then we go to subtraction, which is what you had the most difficulty with. It says a positive 243 minus a positive 671. Now again, here's why most people have trouble with subtraction, because they don't want to follow the rule. The rule for subtraction is don't subtract. The rule for subtraction is make it into an addition problem. And you don't just poof, make it addition. To make it addition, you have to change the number you're subtracting by to its opposite. So a positive 243 minus a positive 671 becomes a positive 243 plus a negative 671. And again, please notice, subtraction becomes addition by making the positive number a negative number. Minus a positive is plus a negative. Now that I made it addition does not mean I add. Now that I made it addition means I follow the addition rule. And the addition rule, different signs subtract and take the sign a larger amount. I can't subtract this from that because it's larger, so I use the commutative property of subtraction of addition to change the numbers around. And then I can subtract if I borrow from the 7, make it a 6. 11 minus 3 is 8. 6 minus 4 is 2. And 6 minus 2 is 4. And again, I have to take the sign or a larger amount. The larger amount is negative, so my answer is a negative 478. So it's kind of weird, but I changed subtraction to addition, so I actually could wind up subtracting. And you say, well, why didn't I just subtract to begin with? Because if I subtracted without making it an addition problem, I would have got a positive 428, and that would have been wrong. So again, whenever you have subtraction, make it addition first. The next problem said, excuse me, a positive 167 minus a negative 823. And again, the first thing I always do in subtraction is make it addition. And you don't just make it addition, you make it addition by changing the number you subtract by to its opposite. So a positive 167 minus a negative 823 is a positive 167 plus a positive 823. And again, I change subtraction to addition by changing the number I subtract by, which was negative, to its opposite, which is positive. And then I follow the addition rule. I don't add, I follow the addition rule. And the addition rule for a positive plus a positive, same signs, add and bring down the positive sign. So if I add 7 plus 3 is 10, carry your 1. 1 plus 6 is 7, plus 2 is 9. And 1 plus 8 is 9. And again, your answer is positive. And you get a positive 990. So again, sometimes you change subtraction to addition and you wind up adding. But sometimes you change subtraction to addition, you wind up subtracting. And you go, that doesn't make sense. What are you talking about? It depends. If you change subtraction to addition by changing them, you subtract by to its opposite, and you get the same signs, like here, you add and bring down the sign. If you change subtraction to addition by changing them, you subtract by to its opposite, and you get different signs, like we did in problem number 4, then you subtract and take the sign a larger amount. But the key to subtraction is don't do anything until you make it an addition problem first. Now we go to multiplication. Totally different rules. In number 9, it said a negative 42 times a negative 27. Now the first thing is, whenever you're multiplying, the rule is always multiply. That makes it a lot less confusing than adding or subtracting. Because in addition, sometimes you subtract, and in subtraction, sometimes you add. But in multiplication, you always multiply. So you have to first make sure you multiply correctly. 7 times 2 is 14, carry your 1. 7 times 4 is 28, and 1 is 29. Put a 0 here. 2 times 2 is 4. 2 times 4 is 8. That's 4. 9 and 4 is 13, carry your 1. That's 10 and 1 is 11. That's 1,134. And again, If it's the same signs, your answer is positive, and if it's different signs, your answer is negative. It's a negative times a negative, same signs, answer positive. By the way, don't get mixed up between adding and multiplying. In addition, a negative plus a negative, you add in the answer is negative. But in multiplication, a negative times a negative, you multiply and your answer is positive. And that's because multiplying is not the same as addition. The rule says always multiply, and if you have same signs, your answer is positive. Again, the next one, another multiplication problem. It had a positive 76 times a negative 31. Again, you always multiply. 1 times 6 is 6, 1 times 7 is 7. Put a 0 here. 3 times 6 is 18, carry your 1. 3 times 7 is 21, and 1 is 22. Add 6 plus 0 is 6. 7 plus 8 is 15, carry your 1. 1 plus 2 is 3, and then 2. And again, now you determine your sign. Same signs, answer positive. Different signs, answer negative. By the way, these are different signs, a positive and a negative. So that means my answer is negative. And you might say, but Mr. Dude, a large amount is positive, so my answer should be positive. No, that's the addition rule. We're in multiplication. And the multiplication rule says different signs, answer negative. So the right answer is a negative 2,356. Then we go to division. Number 10 said a negative 375 divided by a positive 34. And again, in division, you always divide. But the beauty is the rules that you had for multiplication are the same as your rules you have for division. And that is same signs answer positive, different signs answer negative. So if I divide 34 into 375, 3 goes into 3 once, shift back one place. 1 times 34 is 34, remainder 3. Bring down your 5. 3 goes into 3 one time. 1 times 34 is 34, remainder 1. By the way, here, a lot of you decide to make your remainder a decimal, which you cannot do unless you keep going until it repeats or until it ends. And you don't want to do that in this case because it keeps going for a long time. By the way, some of you automatically round it to the hundredths. You can only round to the hundredths if you're told to or if it's money. This is not money and you weren't told to round. So you'd have to keep going, all right? So you say, well, what am I supposed to do if it keeps going? Make your remainder a fraction, not make it a decimal. And that's easy. So it's 11 and 1/34. However, it's not 11 and 1/34 because I have different signs. And different signs means you make your answer negative. So your answer comes out to be a negative 11 and 1/34. And again, don't make your remainder a decimal. Make your remainder a fraction. Unless you want to keep dividing on and on and on. By the way, I was very concerned. Someone went 7 places and then rounded. The reason I'm concerned is I think you didn't divide at all. I think you used your calculator. Because your calculator will go 7 places and end because the screen ends and it rounds. But you can't do that, okay? If you really wanted to make it a decimal, you would have to keep dividing. And that would be foolish when it's so much easier to make it a fraction. Finally, the last division problem said a negative 239 divided by a negative 76. Again, you divide like normal, 76 into 239. Divide 7 into 23 goes 3 times, shift back one place. 3 times 6 is 18, carry your 1. 3 times 7 is 21 and 1 is 22. Pretty easy division. 9 minus 8 is 1. 3 minus 2 is 1. And again, do not make your remainder a decimal. It's going to keep going on and you don't want to do that. Make your remainder a fraction and it becomes 3 and 11, 76. And again, you got to figure out the sign of your answer. But it turns out in this one, if you forgot to figure out the sign of your answer, you'd luck out and still get it right. Because the the sign in the answer is positive because you have the same signs. A negative divided by a negative is same signs, answer positive. And remember, no sign means positive, so if you wouldn't have put a sign, you still would have got it right. So again, on this one quiz, we dealt with everything you need to know about integers so far. Additive inverse is the opposite. Absolute value is always positive. Compare, think of positive as having, negative as owing, and the one you'd rather is always the largest. Adding, same signs add, bring down the sign. Different signs, subtract and take the sign a larger amount. Subtraction, change to addition by changing the number you subtract by to its opposite and follow the addition rule. Multiplying, always multiply, same signs, answer positive, different signs, answer negative. Division, always divide, same signs, answer positive, different signs, answer negative. And again, some of you did excellent, and some of you had trouble with parts of it. And mainly, either you mixed up the addition rule with the multiplication rule, or you never even used the subtraction rule. You never changed it to an addition problem first. So make sure you know the rules and use the rules.